Chen Chang, and collaborators are Lo Nanzhang, Zhang Wei, and Huan Kai. And the topic is assessing the effects of species sample size and characteristics on the accuracy of species distribution models. Welcome.
Yes. Oh, that podium is so huge. I think I need to one step forward. Sorry. Hello, everyone. My name is Chen Chang. I'm from Taiwan, the graduate student of Department of Forestry, National Zhongxing University. Today, I would like to talk about assessing the effects of species sampling size and the characteristic on the accuracy of species distribution model. If you have any question, I'm happy to answer your question at that section. I will divide the 6 parts in my presentation, which is from introduction to conclusion. So let's talk about today's topic. Modeling the spatial distribution has been an important issue in spatial ecology under the climate change or the dynamic change, of course we know. But it's hard to describe a pattern since you always solve the problem, such as the species trade and the plant community are so complex. And we live in the natural environment full of variety and complexity. For example, Taiwan have a rich forest resource, and we have many mountains higher than 3,000 meters. It causes dramatic change in microclimate and the topography. So it's very complicated. Then the important things, if we consider the cost and the data quality, really available data, it's a limit since the ground data collect is a difficult job. So we want to tackle this problem. We need to know what will happen, affect, and how to avoid. So in that study, we integrate the 3S technology and the stat test tool greatly enhance us to meet that challenge and giving us the ability to describe a pattern in natural over broader spatial scale. And the model we choose, the maximum entropy in that study, since it is a promising new method for recently publication. We also use the bioclimate and the domain model for a basis for comparison. So in brief talk, we integrate those technology and the model to predict the potential habit of single tree species. What kind of species we choose? We choose from central Taiwan. It's a widespread species, Chinese Goga tree, we call the CGT. It can grow 300 meters to 2,300 meters. It's broad distribution, and it have excellent fire-resistant traits and good for filament. The another one, we choose the clown species. Its name is Formosanum rhododendron. We call it FR. They always form a pure forest and have the heavy specialization. They always can grow in normal conditions, but they also can grow in the poor environment, such as sandy, thin, and infertile soil traits. It also can grow very well. The object of that study, we want to check 3 points. The first one, examine how the effect of training sample size affect our models, and does the species trait affect our models or not? And the third one, determine which models are useful plant species. And next, we could see the study area is a rectangle shape, which encompasses the Huishun Forest Station. And Huishun Forest Station is a representative forest in central Taiwan. And so far, we collect the CGT and FR sample collect from the Dongfeng watershed. We enlarge that place to show you the 3D model. The red points our go on site to collect field work job. And we from valley to ridge and ridge to valley and try our best to obtain the data by GPS. Next, I'm going to talk about the flow chart in that study. The database, initially, we create 5 predict variables. That's envelope, the elevation, slope, ascent, terrain position, and the vegetation index from 2 spot file image to create it. Then the species sample size, as we mentioned before the talk, we obtain by the GPS, and the total number we get 122 for CGT and 118 for FR species. Then we could, those species can make sampling design. And we celebrate 2 parts. One part for model development. We randomly choose 10, 20, 14, 16, and 80 sample where use a training data and the remaining the sample will choose 14, will use as test data. And that process will repeat 10 times. So we can get 10 data sets and to input our model to make model robust. That slide shows you we overlay all the layers and to cut the information so we can get suitable and unsuitable attribute data and input our 3 model to calculate the parameter. And that table shows you our 3 model information, envelope the classification method and the feature. Please see the maxim. His core idea is using the entropy value and the Bayes probability. It's a promising new method and find approaching a uniform condition and help. So previous study has to say it's performed very well with the limit data. The second, we use the domain. It's a point-to-point similarity. It's just as we know the information and we can give all sides a similarity value. So we can set the threshold and cut confidence level and to fit it the realized condition. So finally we can get a binary prediction map. And the third one, the bioclimate, is an environmental envelope. It just encloses all the possible size. So it's a very easy and simple way to describe the species pattern. Finally, we need to model validation as an objective before we talk. First, we check if valid sample size by the kappa value. And that value is from 0 to 1 point, and agreement coefficient from low to high and almost, and set Y level. Then we test the species tree by the independent t-test and determine which models we use in the ANOVA test and the post-multiple comparison of the models, and we can know the model difference. And next session, we will talk our study result and our finding. Initially, please see that table to show you the valuable selection. Of course, both CGT and the FR species, and they totally look all together to choose the 3 predictors have the relative the highest important variable. They choose the elevation, slope, and the terrain position were high. So we choose the 3 predictors to build our models. And that can show you the 6 broken lines. And that table shows the relation between the different species and the model performers. As we can see clearly, that the 6 broken lines progressively increase until the 16 number have increased, while only the CGT bioclimate still low performers, but they reach the highest point at the 18 number, and especially for FR domain have the best result. That's indicate the following range to 18 maybe have the best result. Nearly 18, we can get the higher point. So we follow up that result and to infer our model comparison and test the species trace. And next, so we summarize that table to show you we celebrate 2 species and each model performance and the average meaning. And we first to test our species trait, and we find, according to our independent t-test, we find they have a striking difference. That's meaning the mean kappa FR species higher than the CGT species. That indicate the next kind of dispersal and similar CGT species are more difficulty to predict, and so not predict very well. While the FR as plum species, they always can, because they condense, so they can predict very well. Then we further to compare the model performers. Of course, before we have test ANOVA test, and both species have approach significant. Then we can use that multiple comparison. As I show you, in terms of CGT, we could find the maximum some higher than the domain, but they not approach non-significance. And both species, both models are higher than the bioclimate model. And in terms of FR, since the species trait, so each model are not significant, but both species we could find they totally get maximum and domain were much better for predicting according to the model performance. And if we consider the data cost benefit, we also need to wish the happy mat could reduce the field work. So according to our result, we find the maximum domain could reduce the area of field survey less than 10% the total area. That's a huge job and give our very high point the possibility to go to layer and to find the species. So we find, according to accuracy and effectively, the domain and the maxent have better. Then finally, I will show you each model's the spatial omission and the commission error. And in terms of CGT, the green color is our non-heavy background, and the orange color is our heavy, and the triangle white and the pink is the background point, and the red, the sky blue point is our training and the test data. As I show you in large samples to show you, no matter maxent and domain, they will better predict very well, and they could discriminate the non-heavy and the suitable heavy. So it's better for predicting. While the bioclimate model, since it's broadened the potential heavy, it caused the background point in commission error in our potential heavy. So overall the accuracy will decrease. And in terms of FR species, we also compare the same place to show you in large that's problem. And maxent and domain also have the better job, similar like the CGT predicting. While bioclimate affected by species trait, they also predict very well, better than the CGT condition. Well, there's a wrong prediction with the background, since the bioclimate model will broaden the potential heavy, but it's already better than the CGT test. And finally, above some study result, I drew some conclusion below. And first point, the three model with training sample size, we find they tend to rise as the sample size and increase for both species. And the training sample falling with the range from 16 to 18 have for the best but may not be optimal. And that point we may need to check in the future study, since we still not to increase our sample size extend the 100, 122 because the species sample is very hard to get. And we also will make other different spatial pattern to make a sampling design to check that point. And the second, according to our result, we find the species trait will affect our model performance, especially like the widespread species, for example CGD, are generally more difficult for modeling the species, while the clump or the class distribution like the FR species. And the third one, if we consider the cost benefit, we need to both good performers and really help us the field work. So we suggest or recommend the maxent domain model were better for you to choose, because they have good performers and greatly reduce the area of field survey. So that's our idea. And we still the state of primary, so still lose some key factor in our models, such as the data quality and the direct predictor will take into consideration yet. And future study will also attempt to use high spatial resolution and hyperimage data for building model we wish can improve our model prediction. That's my today's topic. Thank you for your attention.
Questions?
Can you talk about the distribution model you use for deriving slope elevation and terrain parameters?
Okay. Sorry, you want to know the thermalization or?
What type or what accurate you use for your distribution models?
The variable selection, or you wish to know the model how to use the predictor?
What is the original resolution for this elevation, shape, and aspect?
I'm sorry, could you repeat again? I cannot.
The resolution or yes. the accuracy of your terrain data?
40 meters.
Spatial resolution and the accuracy.
Okay. Spot image is the multiple spectrum is 10 by 10, and we use the satellite image. The middle infrared is 20 by 20, and the near infrared is 10 by 10. So we, in Taiwan case, it's not enough for predict the natural environment. So we wish to use the hyper image data, for which could help us our model improvement. And we choose other variables such as elevation, slope, and set. It's originated from the DEN, and the terrain position was using the generate to create it. It's a simple way. We divide A level and from valley to ridge, and using the Euclidean relative position to get that terrain position. And we resample the resolution 5 by 5 meters. Yes.
Eventually, you get 5 by 5 meters.
Yes, 5 by 5. Yes.
Okay. More questions? I have a question. You mentioned soil and solar radiation, and one more parameter that are missing in the model. But are you planning to incorporate these parameters in the near future, especially soil types and solar radiation and precipitation? Yeah. So are you going to include them into the model anytime soon?
Okay, thank you for your comment. And I not think that's about that, but it's very interesting because, as we know, of course, in predictive SDN life, we need to focus on the four-type development factor, involve the soil and the climate and the topography and the bio interaction. Of course, we know, but if we, according to the satellite image, we should hopefully easily to get its topography factor. Yes, but in Taiwan case, we live in the subtropical and the tropical zone, so it's very hot and have very complex bioclimate interaction. So it's according to the satellite image is not enough to the spectral and the spatial resolution. That's why we wish could do it. Yeah, future we try to. That's the future trend. Thank you.
More questions?
So what would be the broader impact of your study? Let's say, using models to predict species, people done that. Even you got the best model with your best data. Then what's next? Do you have you have very good prediction of different species. So what would be the implication of broader impact?
In my opinion, in forest, the policy, we need to find stuff like the endangered species. We need to set the conservation or preservation, the set. So we need to find the species potential happy and to find the high potential happy and set a different level and to could make the policy decision. And the second, if we want to know the biotic interaction, we also need the basis model because different species have different species traits. And that species, I show you, that study show you the two different species. One kind is plum species. They always, in the selection is the latter in because they grow very slowly. And the Chinese gold country CGT is a light demanding and always very grow fast. So maybe it's our state of the ecology can to compare that the state and also can make the forest policy decision for the endangered species or other to plan that job. Yeah, it's my idea. Thank you.